Good afternoon, class. Today we're going to recap on how we can actually do proving of Trigo identities. First, we need to take a look at what are some of the important Trigo terms and relationships that you have to keep in mind before you can actually attempt your proving of Trigo identities. Take note, these are nothing new. Sine x is 1 over cosine x, cosine x is 1 over secant x, tangent x is equal to 1 over cotangent x. If you can see, all the first letter here coincide with the third letter over here. So this is the easy way for you to remember. And likewise, tangent x is also equal to sine x over cosine x. The converse is true on this side as well. Okay, I'm not going to go through in full, but you can see that the results over here are all derived from here. More importantly, this whole part you need to remember by heart because the formula list will not be shown. Whereas this whole portion in green, this is another set of important Trigo relationship where it's indicated inside the formula sheet. So I do not need you to actually memorize, but as I say, any square term that deals with Trigo, there is a relationship, always refer to the formula sheet. And with this, I can begin my proving of Trigo identity. First, a thumb of rule. If you want to prove your Trigo identity, it's always very important to start from the more complicated side to the easier side. If you take a look at example A and B, alright? Both the left side is more complicated than the right side. The right side is the simpler one. So, in this case, you start from the left side. In exam situation, I know most of the time we start from the left hand side. But actually, a better advice is, let's take a look at which one is the more complicated side. Do from the more complex side to become the easier side. Let's start with the first example. Alright? You will need to start from the more complicated side, which is the left hand side. So you need to let me know. Now take a look at part A. There are two terms here. There is only a single term over here. So it's very clear cut. If you want two terms to combine into one term, the only approach is change to common denominator. I say again, if you want two terms to become a single term, it must be changed to same common denominator. The reverse is true as well. If you want one term to be split into two parts, very simple. With the common denominator, split it up into two portions. Okay, let's see how we can change to common denominator. Simple reference or simple remembrance. This is 1 over cosine x. Let's change to common denominator. Alright, this will be what you will actually, this will be what you have. Now, see, there is a square term here. Remember, it's always very useful for you to refer to the formula sheet. Let's take a look over here. 1 minus cosine square. In this case, we'll be able to derive sine square. And you know, sine square is the same as sine x multiplied by sine x. And if you were to write it out, you can see that we can have the first term together this way. Alright, sine square is the same as sine x multiplied by sine x. So in this case, I can write this as sine x over cosine x as tangent x based on your memory. Very good. It's exactly the same as my right hand side. Proven or shown. as indicated in the question. With that, we are done for part A.